Electrical diagrams are the most common topic in our 9th grade physics. If you haven't understood electrical diagrams during summer break, then you'll struggle to keep up when school starts. Back to basics. For those who love physics class, we'll learn these 3 states of electrical diagrams in 5 minutes. Please note, there are more tutorials on the homepage. Okay, let's first look at this. The simplest electrical diagram looks like this. It has a power source, it has connecting wires, it has a light bulb, it has a switch. All right, what we need to note is the switch in the new textbook looks like this. It's missing the small circle. We need to pay attention to this. Specific details depend on your textbook. It's just a slight difference. We see the switch has 2 states. That's what we commonly refer to as you press to turn off the light, you press to turn on the light. What's the professional term for this? It's called switch closing. What does closing mean? Because initially it's not lit. This switch is not connected. The circuit isn't connected. Closing means it's connected directly closed. So the switch was originally like this. When connected, it's closed. What about opening? Opening means not connected, not closed. It's broken here. That's what opening means. So actually, closing is what we call turning on the light. Opening is what we call turning off the light. Now we see 3 states of electrical circuits. What's a complete circuit? A complete circuit is under normal conditions. Current flows in a complete circuit. A complete circuit is the normal state. The current is connected after the switch is closed. The current flows through. Then the light bulb lights up. This is a complete circuit, easy to understand. When current flows, it's a complete circuit. What's an open circuit? An open circuit is when it's broken somewhere. For example, if it's broken here, it's not connected, so no matter what, the light bulb won't light up, the circuit won't conduct electricity, or even if it's not broken here. If we don't close the switch, if the switch remains open, it's also an open circuit because it's also broken. It's also not connected. The 3rd state is a short circuit. We hear about short circuits in daily life, like saying your brain is short-circuited, but your brain's light bulb isn't lit, your brain isn't working well. That's what short circuit means. There are 2 types of short circuits. One is called power source short circuit. The other is called local short circuit. So what is a short circuit? A short circuit is in this situation. So it's like this. The current connects like this, but how? But here there's an extra wire. If there's an extra wire here, it connects both ends of the bulb. So if that's the case, when this switch closes, current won't flow through the bulb. Instead, what happens? It goes through the wire instead, directly back to the negative pole. This situation is a short circuit. A short circuit will burn out the power supply. A power short circuit will burn out the power supply. Why does a short circuit happen? Why does current flow this way? You can think of it like this. There are 2 paths in front of it. One path goes through the bulb. One path goes through this. Why does it only go through the wire? Why not through the bulb? Now think about it this way. Current flowing into the bulb has to consume electricity to make the bulb light up. It must consume energy. Just like going to school. School consumes your energy, consumes your emotions, makes you feel weaker. So there are 2 paths. One path. Current goes straight home. Other path. Current goes after school, then returns home. So now would the current prefer to go straight home, right? Exactly, it doesn't want to study at all, so it won't go through the bulb. So when this wire appears, it finds a direct path back to negative. It can skip school, go directly to the negative pole. It can go straight home. It won't take the other path. So these situations are the same. Equivalent to this situation, the bulb has no function. It's basically just waste. Current goes straight to negative. Good. This is a power supply circuit. A power circuit is the wire. It has a path, directly connecting positive and negative, no matter how complex the middle path, even adding 1 bulb, 3 bulbs, 4 bulbs, no matter how complex the circuit. As long as you find there's a wire that bypasses the bulb, connecting positive and negative, then current will only flow here because it found the easiest path. This is a power short circuit. Now about local short circuits. A local short circuit is when the power isn't shorted, just a specific bulb is shorted. For example, here, look, we have a switch here. After closing it, you'll see the current will definitely flow through. L2 will definitely have current. Then in front of it, there are 2 paths. One path goes to L1, one path goes to the wire. You see it won't go to L1 because there's a path that bypasses this bulb. It won't go that way, it goes directly back. This is a local short circuit because only L1 is shorted, only L1 has no current. So it's called a local short circuit. That's how circuits work. If you found this helpful, please type helpful in the comments. My goal making videos is to help students in school have a chance at high school admission. I can only tell you, you just need proper guidance and test-taking methods. Don't lose hope. I was once a struggling student. Starting from just 30 points to scoring 80 in high school, because I developed physics problem-solving methods. I teach these methods to my students. These are our 2025 semester students. If you want to improve and see results from your efforts, click the icon at bottom left. Click on customer service. What topics do you want next time?